Good morning, students. We are last class discussed about some basic concept of organic reaction. There mainly we are studying that the covalent bond. Covalent bond, we know very well that the mutual sharing of electron. Otherwise, between the atom as mutually sharing the electron, this bond formation is known as the covalent bond. Okay, last class we discussed about that the cleavage of covalent bond. The two types of cleavage, homolytic cleavage and heterolytic cleavage. Okay, the homolytic means there is a symmetrical cleavage. The both sides of the atom has the same molecules are present or atom is present. Then heterolytic cleavage, we are discussed about that one side and both the left side and right side has the not equal atoms are present there. Okay, then hybridization, we discussed the nucleophilic, electrophilic, that and all over. Okay, today we are going to study about the resonance or mesomeric effect. Okay, resonance or mesomeric effect. First to see that the definition, resonance or mesomeric effect. The resonance or mesomeric effect, only we observe the organic compounds. Okay, only we observe the organic compounds. These organic compounds more than one more structure. Okay, more than one more structure. This structure are only the bond position is different. Okay, it is represented by more than one structure. Okay, more than one structure, and the bond position is the different. Okay, I will explain one example. Okay, the example is the 1,3 butadiene. Okay, 1,3 butadiene. Before that, I will tell you the butane. Okay, butane means the 4 carbon atom. Okay, 4 carbon group is known as the butane. I will draw the structure CH3. I will draw the structural formula CH3 C CH3. Okay, this is the formula of butane. Okay, careful, listen here. Okay, this is the structure of the butane. Okay, where example is 1,3 butadiene. Okay, 4 carbon atom, 1, 2, 3, 4 carbon atom. First to put the number 1, 2, 3, 4. Okay, so first carbon atom and the third carbon atom is the diene group. Diene group means the double bond group. Okay, first you see, this is the first carbon atom. Here the double bond, then the third carbon atom, here also double bond. Okay, when the double bond is come at that time, this is the 2 hydrogen atoms, this will disappear. That means the 2 hydrogen atoms is the mutually shared them electron. Okay, so this 2 hydrogen is displaced from this group. When it is displaced from this group, it became the double bond or pi bond is present here. Okay, then third carbon atom also 1,3 butadiene. So the third carbon atom also contain the 1 hydrogen atom. Then fourth carbon contain the 1 hydrogen atom. These hydrogen, both hydrogen atom replaced. When it is replaced at that time, we get this make one pi bond. Okay. So this is the 1,3 butadiene. Okay, the 2 double bond is present there. So diene. Otherwise, this is one single bond means, one double bond means this is a butene, but here is the 2 double bonds. So it is the butadiene. 1 and 3 group, it is the 1,3 butadiene. Now we are studying the resonance. Okay, the resonance means here see. First the alpha hydrogen atom. Okay, this alpha hydrogen atom is occurring in the resonance effect. So here the first double bond, this is the first group double bond will be delocalized. Okay. The resonance structure, I will draw the resonance structure. You see CH2, this CH2, then this the pi bond is delocalized. So it is the displacement, one place to another place. So it, here come the single bond. When it get a single bond will come, here the deficiency of the electrons. Okay, deficiency of the electron, it is mentioned by plus charge. Okay, then CH, then double bond. This bond is moves to the next carbon atom. So here the double bond will come, then CH, single bond. This the bond will be replaced from this place. Okay, so single bond CH. Here the extra electron, so here is the minus charge will come. Okay, this is the one resonance structure. Okay, the next resonance structure is the same way. Here the first carbon atom containing the pi electron is delocalization occur here. Here the second resonance structure, the fourth carbon atom containing the pi bond is delocalization. Okay, so so the pi bond delocalization like this. So CH2, here a single bond, because the pi bond is delocalized. CH, double bond, this the pi bond is delocalized, the third carbon atom. So here I get the double bond, then CH, then this is double bond, it is the delocalized. Here the delocalization occurs, so here is the not sufficient electron, here is the sufficient electron. Okay, this is the resonance structure of 1,3 butadiene. Okay, this is the resonance structure of butadiene. It is generally when it is drawn that the Mesomeric effect for the 1,3 butadiene, CH2, CH, CH, CH3. They indicated the dotted line because this is the pi bond is the shifting. Okay, then this is the resonance or Mesomeric effect. It is the two types. Okay, one is the positive Mesomeric effect, another one is the negative Mesomeric effect. Okay, the positive Mesomeric effect, the electrons move away from the away from substituent. Okay, that is the one condition. The second condition, the substituent tendency to releasing the electron. The substituents, it is tendency to releasing the electron. Here the example OH and thio, then amine group, then oxy group. These are the example of the positive Mesomeric effect. Okay, I will give the one example, that is the phenol. Positive Mesomeric effect. Okay, here is the three conditions. First one is the move away from the substituent. Okay, the electron it is move away from the substituent. Second condition, it is the electron releasing substituent. The second condition, the electron releasing substituent. Then the tendency of the substituent is the electron releasing. Okay, this is an example, hydroxide group, thio group, then amine group or etc. Now I am given the example of phenol. Okay. This is the structure of the phenol. Here is the two lone pair of electrons is present. First one, this lone pair of the electrons is delocalized. At that time, this electron is delocalized. The resonance structure is this is the lone pair is delocalized, so here is the double bond will come. OH, then this is come also, the minus charge. After that, no changes here. Okay, then next resonance structure, Next resonance structure, here is no change. This electron is moved here, then this electron is come here. So resonance structure is then next resonance structure is this electron is moving here. So this is here is no change. The next resonance structure is the come back the original state. So this electron is moved here. This is the resonance structure of the phenol, the positive mesomeric. Listen, the condition first it is the substituent. The substituent means the attaching group. The attaching group is the OH. Okay, this is the substituent. The substituent tendency to release the electron. Okay, here this is the lone pair of the electron will be released to the benzene ring. Okay, this is the condition. The next one is the negative. The one more example is given in the book. The phenoxy group. Okay, the phenoxy group. Phenoxy means the previous one phenol, this one is the phenoxy. Phenoxy means only oxygen is present here. So 3 lone pair of the electrons. Now this lone pair of the electron move here. So the double bond will come. Oxygen, one lone pair is moved here. So here is the only 2 lone pair of the electrons. Then this electron, the second structure, this electron is moved to here. This electron move here. The next resonance structure, this is move here, then this one. The next structure is this electron move here, so just come back the original state, the first state. The single bond will come, oxygen, 3 lone pair of the electron. Okay, this the phenoxy group is the more stable than the phenol group. Then negative mesomeric effect. The negative mesomeric effect means likely opposite of the positive mesomeric effect. That is the tendency to withdraw the electron. This is the tendency to gain the electrons. Okay. There is the substituent group. It is the tendency to release the electron. Here the substituent group is the gain the electron. For example, nitrogen oxide, Karungal group, acid and cyanide group. Okay. The next topic is the hyperconjugation. Hyperconjugation means first we discuss about the pi bond. Okay, here we are discussing about the sigma bond. The that is the delocalization of the electron of sigma bond is called the hyperconjugation. Okay, the first we have the resonance or mesomeric effect we have studied. There is the shifting the pi bond. Okay, the double bond. Okay, this pi bond. Here is the delocalization of the sigma bond is known as the hyperconjugation. Okay, this sigma bond is the interact with the non electron containing the p orbital. It is the interaction between the no electron p orbital and the sigma electrons. Okay, the interaction sigma bond. Then also it is the non-bonding p orbital. Then sigma anti-bonding and pi anti-bonding. Okay. Then this is the example we have discussed the propene. Propene is the last we have discussed that the 4 carbon atom, that is the butane. This is the propene. Propene is the 3 carbon atom. CH3, CH single bond, CH2. This is the formula of the propene. I will write the structural formula. See, the first thing is we are discussing about the pi bond is the delocalization. Here is the sigma bond is the delocalization. The sigma bond is delocalization. It means the single bond is delocalization. You see, this is the first carbon atom containing the 3 hydrogen atom. Any one of the hydrogen atom, it may be this hydrogen atom. It is the delocalized. That time this the structure is formed: carbon, hydrogen, 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 positive charge. This hydrogen does not move anywhere, but it is in the position only, but here is no bond will occur. Okay. Minus charge. Then next delocalization. The same thing only. First this the hydrogen is the displacement. Then second thing, this hydrogen is the displacement. So carbon, hydrogen, this hydrogen, it is here only, but it is not connecting the bond. The next structure, this hydrogen. Okay, this is the alpha hydrogen. Okay, this is the 3 hydrogen is also known as the alpha hydrogen because this is a carbon containing the hydrogen. So now this hydrogen. This is the hyperconjugation. The hyperconjugation, it means the delocalization of sigma bond electron. Delocalization of sigma bond electron is known as the hyperconjugation. That means the interaction between the sigma bond and non-bonding p orbital. Okay, non-bonding p orbital or sigma antibonding or sigma pi bond. Okay, this is the example. This is the first structure. The first structure. The second one. Then third one, then this one, fourth one. Okay. Then the example 2, the condition is that having lone pair of the electron is attached by the single bond. Okay, the lone pair of the electron is attached by the single bond and conjugated with the pi bond. Here the example, ethyl chloride. Example 2, example ethyl chloride. Cl, the Cl containing the 3 lone pair of the electron You see here condition, lone pair of the electron is attached to sigma bond and conjugated with the pi bond. Okay, so the structure will come. This bond is moved from here. So CH2 minus single bond CH double bond Cl. One lone pair of the electrons moves from here. So this is the lone pair of the electrons condition. Okay. Then the third condition is the electronegative atoms or group of atoms is conjugated with the pi bond. The electronegative atom is here, example, the cyanide group. The cyanide group. This also ethyl cyanide. This is an example. Here the electron's movement. This is the pi bond. This move here at that time. This one move to here. So this is the arrangement. So here is the this is the electronegative atoms or group of atoms conjugated with the pi bond. Okay. The next one is the hydrocarbons. The next lesson, hydrocarbon. Hydrocarbon. First to listen there. Already we discussed about the organic compounds. The organic compounds means carbon and hydrogen. Okay, without carbon and hydrogen, no organic compounds. First to understand, this is the electronic configuration of the carbon atom. Okay, the carbon atom has the 6 electrons. Okay, the 2, 4. This is the electronic configuration of the carbon. Okay, the first cell containing the 2 electron, the second cell containing the 4 electron. Okay. So, according to the 8 electron rule or octet rule, that is says that only the outer cell containing the the 8 electron, that's the atom. Okay, I will discuss the hydrocarbon next class. Okay, dear students. Okay, thank you.